Good afternoon, everyone. My name is Dr. Ajaz Hussain. The title of my presentation is Detecting Recent Change in Land Use and Land Cover in Kailash Secret Landscape India using Geospatial Techniques under the project Kailash Secret Landscape Conservation and Development Initiative. As all of you are aware that the KSL is a multi-scale project being implemented by three countries, that is China, India and Nepal. In India, the partner organizations cover the eastern part of Uttarakhand, which is the whole Pithoragarh district. The total area of the landscape is 31,000 square kilometer, of which India shares 7,000 square kilometer approximately. In order to develop our understanding on initiate different management planning, different components were identified to fulfill the research gap in the Indian part of KSL. The current study comes under the component number 4, which is the long-term ecological monitoring. Kailash Secret Landscape is a human-dominated landscape. It is culturally and ecologically rich. Apart from one protected area, that is Ascot Wildlife Sanctuary, the landscape is dominated by community forest and reserve forest. Due to urbanization and landscape conversion from forest to agriculture, there is an increase in forest degradation and fragmentation, which has led to land use and land cover change at landscape level. Based on the field survey and secondary information, we perform land use and land cover change in Indian part of KSL. In this presentation, I will be covering background, objectives, and key findings of the study. The Kailash secret landscapes are undergoing unrepresented changes due to anthropogenic and climatic drivers. Landscape degradation, such as deforestation, conversion of forest land into agriculture and build-up areas, are the major issues, environmental issues in this region. The present study focused on the Indian part of KSL, which covers whole Pithoragarh district. The present land use and land cover study in the landscape is designed to fulfill the gap to provide detailed information about the total area change in last 2 decades using satellite and remote sensing geospatial techniques. Therefore, this study applied GIS technique to analyze and spatio-temporal to analyze and see the spatio-temporal change at landscape level during last 2 decades, which is from 1995 to 2015. We use remote sensing data from Landsat 5 for the year 1995, Landsat 7 for the year 2005, and Landsat 8 for the year 2016. The Landsat image consists of all bands starting from 1 to 7 and have a ground resolution of 30 meters. 30 meters. We perform for the supervised classification in ADAS image. The maximum livelihood classification algorithm was used for classification. We use cross distribution model to detect methods to detect land use and land cover change in ArcGIS 10.3, through which land use and land cover matrix table and maps were produced. The land use and land cover map for the year for the year 1995 2016 were prepared with 7 land cover types, namely forest cover, barren land, settlement, forest cover, glaciers, water bodies, agriculture, and rangeland. The result from the supervised classification of the image 1995 2016 1995 to 2016 indicated loss and gain in various land use and land cover types. The area covered by agriculture reduced drastically between 1995 to 2016, with an increase in built-up area, rangeland and barren land. For the estimated, there has been a significant loss in the agriculture area, where the agriculture area with respect to 524 kilometers square, 453 kilometers square, and 432 kilometers square in 1995, 2005, and 2016 respectively. There is an overall reduction of 100 square kilometer agriculture between 1995 to 2016, which might be because of the during this study period, we found that most of the people, they do migrate from villages to cities, and they abandon their agriculture areas as the forested, as well as their villages. Later, those abandoned agricultural land and forested area converted into scrub land, as well as in rangeland. During last 2 decades, there's an increase in the forested area, which was 2,000 square kilometer in 1995, 2,170 kilometer in 2005, and 2,186 kilometer in 2016. A total of 184 kilometer square area of the forest are increased in the landscape during 1995 to 2016. The increased forest may be due to, as I earlier mentioned, because of the protection of local communities to their community forest. Once they protect the community forest, the local people start The local people stop collecting fuel, wood, and fodder from the community forest. This might be one reason. Because of that, the area of the forested areas increased in the landscape. The land use and land cover map from the year 1995 to 2005 and 2005 to 2006. Land use and land cover analysis through GIS across interpretation produced showed changes in area of individual land use and land cover types between 1995, 2005, and 2016. To know the extent of settlement in KSL India, we also use night light data from the year 2018, 1995 to 2000, and 2018 to 2014. As you can clearly see in these maps, that the district headquarter and the block headquarters are, there is an increase in human settlement. We can clearly see through this map. The result shows that the significant change in land use and land cover in Kailash Secret Landscape India between 1995 and 2016. The agriculture, settlement, forest, and range land, range land increase in the glaciers also increase in the landscape. 100 square kilometer of agricultural land in KSL India was changed into forested area and human settlement between 1995 to 2016. 64 square kilometers of agricultural land converted into forest land. 32 square kilometer of agricultural land converted into human settlement. The human settlement, especially in the district headquarter and Tehsil headquarter in KSL India, had increased by 50 square kilometer during 1995 to 2016. With this, I would like to thank the Dean Director of Wildlife Institute of India, ICMOR, for the funding, team KSL, and field assistant, and the Panchayat committee. Thank you for your patience listening. Thank you very much.